In this video, we'll discuss regarding two-point sources with currents of equal magnitude but with opposite phase, which is case 2. This case 2, case 1 is two-point sources with equal magnitude and same phase. Okay, same thing. Now case 2, that is two-point sources with the currents of equal magnitude and opposite phase. Okay, so here the only difference is here the magnitudes are equal, but the phases are opposite. Here the phases are opposite. Okay, so let us consider this is the origin. Okay, so let us consider this is point source A1 and this is point source A2, and both are separated by a distance of B. Both are. Let us consider this is point B. No doubt A2 will reach point B earlier when compared to the A1. Okay, so what is the path difference? The path difference is nothing but automatically d cos theta. Okay, so if you apply this, the path difference is nothing but d cos theta. Okay, so the value of ET, the total electrical field at ET, the total electrical field at ET can be combination of both. Here, in the previous case, I have taken one point negative side and one point positive side. Here, I have taken the at origin. Okay, so the total electrical field, I can write it as. So here, what is the thing? Equal magnitude, but with opposite phase. Okay, so ET can be written as E naught plus E naught into e to the power of j psi by 2 plus pi. Here 180 degrees I am taking opposite phase. Okay, so it is E naught plus E naught into e to the power of j psi by 2 into e to the power of j pi. Okay, so what is the value of e power j pi? It is so that is E naught minus E naught into e to the power of j psi by 2 means if there is 180 degrees phase shift, we get here minus. Okay, so let us consider the total electrical field at point P is E1 plus E2, whereas the value of E1 is equal to E naught into e to the power of minus j psi by 2, because magnitude is same. Here E2 is equal to E naught into e to the power of j psi by 2. Therefore, the total electrical field is equal to minus C1 plus E2. Why? Because minus C1, because that is, if we introduce 180 degrees phase shift, minus coming into picture. Okay, it's the same thing. Okay, so therefore, the total electrical field ET is equal to minus C naught into e to the power of minus j psi by 2 plus E naught into e to the power of j psi by 2. So that is, if I take E naught common, e power j psi by 2 minus e to the power of minus j psi by 2. Okay. So to the total electrical field, it is equal to E naught into 2j sin psi by 2. Okay. 2j sin psi by 2. Therefore, total electrical field magnitude, we call it as 2j E naught into sin psi by 2. Okay, so sin psi by 2 means it is sin psi by 2. Okay, so we know that ET maximum is equal to ET maximum value is equal to, this is the expression for two-point sources with equal magnitude and opposite phase. Okay, so ET max is equal to 2 E naught. ET max is equal to 2 E naught. Therefore, the array factor, what is the formula for the array factor? ET by ET max. ET by ET max, you get sin psi by, okay. So sin psi by 2. Okay, now let us check for different cases. What happened? For example, what happened for 2-point sources with 2-point sources with currents of equal magnitude, currents of equal magnitude and opposite phase. Let us see in which direction we get maximum radiation, in which direction we get minimum radiation, in which direction we get uh, half power beamwidth condition. Okay, so let us take for the first condition, first one, that is for maximum radiation or maximum direction. Maximum direction. Okay, so the maximum direction, that is the condition is the array factor, it is sine psi by 2, sine psi by 2. So the condition is sine of psi by 2 is equal to plus or minus 1, that is sine of psi means what is the value of sine? Beta t cos theta. Okay, if d is equal to lambda by 2 psi. Okay, so we get if d is equal to lambda by 2, we will get sine pi by 2 cos theta is equal to plus or minus 1. Applying cos inverse on both sides, applying sine inverse on both sides, we will get pi by 2 cos phi max is equal to uh, plus or minus pi by 2, pi by 2 will get cancelled. So cos of pi max is equal to plus or minus 1. So we apply cos inverse on both sides. For maximum radiation, we get in 0 degrees or 180 degrees. Okay. Theta direction or theta direction, getting maximum radiation in 0 degrees or 180 degrees. 0 degrees or 180 degrees. 0 degrees or 180 degrees. This is the condition for 2-point sources with equal magnitude and opposite. Earlier in broadside array, we have 2-point sources with equal magnitude in same phase, maximum radiation got to 90 degrees and 270, but here we are getting a 90 degrees, 0 degrees and 180. Similarly, let us check for minimum direction. Minimum direction in which you will get minimum direction. So the same thing, the same condition, sine of psi by 2 is equal to plus or minus 0, where psi is equal to beta d cos theta and delta d is equal to lambda by 2. If we apply that, pi by 2 cos theta is equal to plus or minus n pi, applying cos inverse on both sides, where n is equal to 0, 1, 2, 3, so on. Okay, so for n is equal to 0, cos pi minimum is equal to 0. So for what value you will get? For minimum value or theta minimum value, it is for 90 degrees and 270 degrees. 90 degrees and 270 degrees. Okay, see. Now let us go for half power point. Half power point direction. Half power point direction. So half power means when the electrical field strength has fallen to 1 by root. So the condition is sine psi by 2 is equal to plus or minus 1 by root 2, where psi is equal to beta d cos theta and d is equal to lambda by 2. Okay, so substituting this, sine of pi by 2 cos theta of our point is equal to plus or minus 1 by root 2, applying sine inverse on both sides. Sine inverse on both sides, we get pi by 2 cos theta of our point is equal to plus or minus 2n plus 1 pi by 4. Pi will get cancelled. Okay, so that is cos theta of power is equal to plus or minus 1/2. Therefore, theta of our point is equal to 60 degrees and 120 degrees. Okay, so this is the expression. Now, let us summarize this for 2-point sources with currents of equal magnitude and opposite phase, we are getting maximum radiation in which direction? 0 degrees and 180 degrees. Minimum radiation in 90 degrees and 270 degrees. Half power point direction in 60 degrees and 120 degrees. So based on this, I will draw the graph. Okay, so this is theta is equal to 0, 90 degrees, 180 degrees, that is 270 degrees. So maximum radiation are getting at 0 degrees and 180 degrees. So maximum radiation are getting at 0 degrees and 180 degrees and half power points. If you draw this graph like this, half power points. Okay. So this is 60 degrees and 120 degrees opposite like that.